Good morning, students. So once again, welcome back to the continuity of my lecture. So in the last class, we discussed about some of the applications of deterministic dynamic programming algorithm. Today class, we are going to discuss the another application. It's called the workforce size problem. So what it means, the workforce size. So when you are considering a project, so what is your main motivation? That project should be completed within a stipulated time with the reasonable or the minimum number of labors we are going to consider to complete the project in a stipulated time, right? So if you go for thinking about more laborers to complete the project, then the company or the contractor get loss. In other words, you have to spend more money. The other way, if you think it, if you go for fixing the laborers with a less number of laborers, then you cannot able to complete the project in a stipulated time. So that is, we cannot able to fulfill our demand, right? So keeping in mind this one can think it about how to maximize our profits with minimum number of laborers so that we can complete the project in a stipulated time. So that is the main idea behind this topic. So let us take a little bit the mathematical sense. What are all the parameters we have to introduce here so that we can try to put this one in the mathematical equation. So let us discuss now. So workforce size problem. So already I given the small introduction. So given the project details like a estimated number of employees in each time period. So for a given estimated number of employees to the project, a contractor have a particular number of employee in his company. Then the contractor has to hire or fire some employees, right? So suppose if there is a the minimum requirement of laborers is demand, then we have to take hire outside, right? Or suppose you are going the other way, you are keeping more number of employees, then what you have to do? Excess number of employees, then you have to give some assignment to the laborers. That is the meaning of fire here. So naturally, to complete the project, we need a stable workforce, right? That is, we should be put the project in a stable sense. So that is the thing. Say I recall it already. So too many employees, if you are employed, then you have to pay more money. If it is less number of employees, then you have to meet. You cannot able to meet the demand in a time. So both things are not good, right? So that is the thing. Meaning a stable workforce. So in this situation, we need to put a proper plan to start our project. So we have to consider a particular elements that is called the dynamic programming elements. So here in the dynamic programming elements, these are all the elements we have to consider. One is the stages, that is talking about the time periods. Next, the number of employees, it is nothing but denoting the states. And the decisions, whether here we have to hire the laborers or we are going to fire the laborers. And some the mathematical notations. N denotes the number of plan periods. BI denotes the minimum number of workers required in a particular week or a month or year, whatever things. And XI denotes the actual number of workers in the week I. And C1 denotes the we are going to pay the cost, the number of excess workers, for the number of excess workers. So here the number of excess worker is denoted by xi minus bi. So bi is nothing but the minimum number of workers we already discussed, and xi is the actual number of workers. And similarly, the C2 is nothing but the cost of hiring additional workers. So how do you compute the additional workers? Nothing but the from the current and the previous week the number of workers, actual workers. So taking the difference, that is nothing but the number of additional workers, nothing but xi minus 1. Right. So based on this parameter, we can put it the mathematical formulation, the recursive equation, nothing but fi of xi minus 1. It's talking about the optimal cost, right? That is, sorry, optimal labors we are going to utilize so that we'll get the optimal cost. So it is denoting like this. Minimum number we have to consider naturally, that is we have to utilize the minimum laborers, right? So that is the first one, C1, nothing but we already discussed, that is we are going to spend the cost for the excess workers plus the cost for hiring additional workers plus the previous output fi plus 1 of xi. So naturally, if I consider I equal to n, then it is naturally it is not exist. Therefore, we put 0. That is at the initial stage, we consider it is a 0. That is the meaning here. So based on this recursive equation, let's go for an example for this workforce size problem. So consider this example. A construction contractor estimate the size of the workforce needed over the next 5 weeks. And they consider the minimum number of workers is 5, 7, 8, 4 and 6 respectively. Right. So that is in the first week, the minimum number of workers to do the project is 5, and minimum number of workers for the second week it is 7, and go and so on. And the thing here, excess laborers kept on the force will be cost $300. So in this problem, we put it in the dollar form. Maybe if you want, you can convert in the rupees. So $300 per worker per week. And new hiring in any week, it will include a fixed cost of $400 plus $200 per worker per week. So what is this meaning? If you are hiring in any time, then this is the 400 fixed rate. That is, you are going to hire from a particular company or some agency like that. So that is the things here. Plus for each and every workers, we have to pay $200 per workers per week. And now the question is what? To find the number of laborers per week such that the total cost of laborer needed to complete the project in a minimized duration. Right? So this is the thing. So based on this observation, we can put it in the standard notation because these are all denoting the minimum number of workers for each and every week. Therefore, we can put in the standard notation. So here the n denotes the number of weeks. Therefore, 5 weeks, right? And for the first week, the minimum number of laborers 5, and for the second week, the minimum number is 7, and similarly so on up to the 5th week. So it is given and denoted by B1, B2, B3, B4, B5 and so on. And we already discussed this is the C1, nothing but the cost of the excess workers. So that one here we'll put it. That is, we are not utilizing some particular workers, right? So they are in the rest. So for that we have to pay. So in that case, what is the things? It is clearly given. It is clearly given here. That is the excess laborers. For that person, we have to pay a $300 per week per worker. So therefore, 3 times the xi minus bi. So that is the thing. So here $300. So every $100 we put it in a single notation. That is the things here I'll make it. $300 that is shortly denoted by 3. It represents the it is a product of hundreds, right? So similarly $400, similarly $200, we put respectively 3, 4, 2, right? So now similarly going for this case C2, this is the already we defined what is C2 means, nothing but the difference of the workers from the previous week and this week, right? So therefore here the $400 is a fixed cost, you have to fix it, that is denoted by 400. For each and every worker you have to pay $200, therefore 2 into the difference of the workers. So xi minus 1. So these are all the things we observe. Now putting this one, observing little bit clearly, what is this meaning? In the first week minimum 5 workers is required. So what is this meaning? 5 workers is required means you can go minimum 5 and maximum up to the maximum value here. If you observe, maximum you can incur the labors up to 8. That is the meaning. So therefore, so minimum labors 5 in the first week. Therefore, I am going from 5, 6, 7, 8. So you can place the labors more than 5. That is the meaning. So you are going up to 8 laborers. That is the meaning. So similarly for the second week, it is given that the minimum is 7 laborers, 7 workers you are going to accommodate. So therefore your minimum is 7. Therefore you can go maximum up to 8. Therefore 7, 8. So similarly for the third week, it is given a minimum laborer is 8. So naturally minimum is 8. Therefore I have to go only 8 only, right? So similarly, for the fourth week, the minimum laborers is 4. Therefore, you can go up to 8. Therefore, you can place the up to 8 laborers. So 4, 5, 6, 7, 8 laborers you can put it. So similarly, thing is the last week, the minimum is 6 laborers. Therefore, you can go up to 8. Therefore, 6, 7, 8. So these are all the observation from the statement. Now using the backward recursive. So always the safest side to complete this problem is the backward recursive cases. So already we discussed this case. You maybe remember this. So therefore we can start from the backward sense, that is from stage 5. That is we are starting with the 5th week onwards, right? So that is B5 with minimum laborers is what? So 6 laborers. So here I have wrongly put it. It is not 5. So it is 6 laborers. So here you can observe this case. So 6 laborers. So with 6 laborers going for the next week, that is next week means what? You are going for the 4th week, that is stage 4, right? So in the stage 4, the minimum laborers is, you can observe here, the minimum laborers is 4, right? So with respect to the 4th week, sorry, with respect to the 5th week, we are going for the 4th week. So with 4 laborers, minimum 4 laborers. So therefore we can put it in the mathematical form. So that is the, here I'll put I equal to 5. You are talking the minimum cost, that is put I equal to 5. So F suffix I within bracket of xi minus 1. So that is x4. So already we put the formula there, you just substitute it. So xi here, so here xi, so here xi minus 1, so here xi, that is the thing. So here xi, sorry, I plus 1. So you put I equal to 5, so you'll get this formula. And naturally, I already told that if you going at the end stage, that is fn plus 1 of xn is nothing but 0, right? So this is at the initial stage, you are not having any workers. That is the meaning. So we have to assume like that. Therefore, this part is become 0. Now substitute remaining values. So B5, that is at the 5th week, the minimum laborers is 6. It is given, and remaining things we can put it in the table sense. So these are things with respect to the week 5. We are going for the next week, that is 4. So based on the above observation, we will put here. So xy equal to 6 and x4 equal to starting from 4 to 8. So here you will substitute xy equal to 6. Therefore C1 of 6 minus 6, right? And here xy is 6. So 6 minus x4 is nothing but 4 in this case. So that is the things here I will put it. So the formula for C1 is nothing but 3 into xi minus bi. So that is xi, here that is x5, and b5 is nothing but 6, that is here I put it. So similarly for C2, so 4 plus 2 xi minus xi minus 1. So here x5 minus x4. So here x5 is 6 and x4 is 4. So substitute here. Simplifying this, you will get 8. So based on this week, we are talking the previous week. So similarly going for the remaining stages also, that is if I consider x4 equal to 5 with x5 equal to 6, then you will substitute here x4 equal to here 5 and x5 is 6, here x5 is 6, you will get this value, nothing but 6. So similarly going for at the stage of x4 equal to 6, So here you will substitute xy equal to 6, 6 minus 6 here. If I put xy equal to 6 and x4 equal to 6. So naturally this will be what happened? It is meaningless, right? Because in this stage, you have 6 labors and 6 labors you are going to recruit for the next week, right? But it is 0, no labors required. That is the meaning. So presently I have a 6 laborer, right? So this is the meaning. Presently I have a 6 labors and you need to go for the next week with 6 labors. So what is this meaning? You are going to utilize the same 6 labors. You are not going to uh, appoint another or some other labors, right? So already 6 is there, so therefore you utilize that 6. Therefore this part will be 0. So similarly, going for the remaining case, here you are having 6 labors, but the thing is what? In the next week I have to go for 7 labors. So that is not possible, right? So if you substitute here and simplify, these parts are all get zeros, right? So naturally, if you substitute all those things, so here if you think it about here in the mathematical sense also, xy equal to 6, x4 equal to in this case 7. So 5 minus 7, that is not meaningful manner. That is the negative laborers is not allowed, right? What is that meaning? The required laborers you are having. So therefore you are going to utilize it, right? You are not going to in the negative sense. So this is the meaning. So therefore these are all zeros, right? And now the thing is going for optimal solution. So what is the optimal solution? Here, if there is two choice, then I can choose the optimum. But here only one choice. Therefore, I put the Fi x4 is nothing but the same things 8, 6, 0, 0, 0. Now this one given by the x5 equal to 6. Therefore, the optimal x5 asterisk, that is x5 asterisk means optimal. So it is given by 6, right? That is 6 laborers. So all these things are same, no change. Therefore, xy equal to 6, 6, 6, 6, 6, 6, everything. Here I'll put it. Now the thing is, based on this fourth week observation, I have to go for the third week, right? So therefore, I'm going for with assuming the stage 4, that is week 4, with the B4 equal to minimum what? Minimum is you need a 4 laborers, right? So minimum 4 laborers. You are going for moving for third week, right? So based on the current information, you are moving for the next week, that is third week. So there, the minimum laborers required is 8 laborers, right? So therefore, again, I have to put the formula here. So put I equal to 4. So Fi x I minus 1, right? So F4 x3 equal to the excess laborer cost, that is put I equal to 1. So x4 minus b4 plus, that is the additional workers. So cost C2 of x4 minus x3 plus here this will be exist because the previous from the previous table it will be exist. So put I equal to 1. So you'll get I plus 1. So here xi. So that is F5 x4. So this is the formula. So based on the previous week, that is week 4, I am going for week 3, right? So week 4, how many cases we have discussed? 4, 5, 6, right? So here 4, 5, 6. So that is the things here I will put it. So x4 equal to 4, 5, 6, 7 and 8. And now we are going for the previous week, that is 8, x3 with the minimum laborers 8. It is given. Now again applying this formula here, you'll get the answer. Or in other way also you can logically apply it. So here x4 minus b4. So x4 b4 is 4. x4 is, if you consider 4. So here what is the things? 3 times x4 minus b4, right? So 3 times x4 is 4, b4 is 4. Therefore 4 minus 4, 0. That is the things here reflected. Plus here what happened here in this case? C2 of x4 minus x3. So here what is the formula? 4 plus 2 times x4 minus x3. So x4 is what? 4, x3 is 8. So this is meaningless. Am I right? Because here you are having only 4 laborers, but the question is here that for next week you need 8, right? So that is not possible. So therefore that will be getting 0. And Fi x4, what is Fi x4? In this case for x4 equal to 4, what is F5 x4? From the previous table we can clearly observe the optimal thing is nothing but what? It is 8. F5 x4 is 8. So therefore, that is the things here. So similarly, going for x4 equal to 5, right? So substitute here f5, x4 is here 5, therefore f5 of x5, the 5, here you can from the previous table, the optimum value for 5 is 6. So that is the things here, we'll paste it. Now simplifying all these things, so similarly, if you keep on moving, the next stage, you'll get this case, right? So here, what happened here in this case, that is also 0 in the previous table, f5 of 6, that is here we are observed it is 6, right? So similarly, going for the remaining cases, x4 equal to 7 and 8. So what is this meaning? You have only 7 laborers, but you are asking for 8 laborers, so that is not possible. So therefore it is meaningless, therefore I'll put dash for the case 7 and 8. So here I'll give the reason, since the minimum 4 laborers required, right? 4 laborers required, but you have x4 equal to 7, right? It is not possible, right? So in this case, I think you are clear. Now again, like a previous table, you are taking the optimum, right? So among this row, which is the optimum, that is either 8, 9 or 6. So the optimum means here, what is the meaning? We need the minimum number of laborers, right? Workers. So therefore, the minimum laborers is 6. That is the things here. So this is given by x4 equal to 6. Therefore, x4 asterisk is 6 here. Right. So now again, based on this week 3, we are moving for week 2, right? So based on this result, so that is the next stage 3, right? So for week 2, with minimum 7 laborers, that is B2, 7 laborers required against the previous week, that is third week, right? So it is minimum laborers is 8. So therefore, I'll put the formula, put I equal to 3. So you'll get this nice formula. Now again, same things for x2 from the previously we are observed, we have the minimum laborers 7. So that is 7 and 8, we'll put it in the first table itself. So therefore here I'll put this, the previous week, it is x3 equal to 8. So based on the third week, I'm moving for second week. So all these things, just substitute here and simplify it, you will get this. For 7, it is 12, for 8, it is 6. Now the thing is what? For this row, the optimum is what? 12, right? There is no any competitor here, therefore only 12 is the things option, no any other option, therefore it is 12. Similarly, in this case also 6. So it is 12 is given by 8, that is the things here put, and for 8 it is 6, it is also 8. So now based on this optimal solution, now we move for the week 1, right? The initial case based on the week 2. So for week 1 with minimum 5 laborers, right, required against the week 2, that is either x2 equal to 7 or 8. That is the previous cases, 7 or 8, right? Or simply you put 7, minimum 7, right? Minimum 7. And plus f3 of x2. So here, that is the things here. So if you go for the week 1, minimum is 5, meaning is what? Maximum you are going up to 8. So that is in the first table itself, we observe it, right? Now substitute all these values and calculate it, you will get this nice table. Now again, the thing is what? 7 and 8. For x2 equal to 7 and 8. For the case of x1 equal to 5, you will get 20 and 19. So you have to choose the optimum. So what is the optimum means here? Minimum laborers we are going to recruit, right? So therefore 19. So it is given by the x2 equal to 8. So that is the optimality here. x2 equal to 8. So similarly in this case 18, 17. So the minimum is 17. It is given by 8. That is the things here and we will put it. So similarly in this case 12 and 15. So 12 is the minimum. So it is given by 7, x2 equal to 7. That is the things here. Put it. Similarly in this case 9 is the minimum. It is given by x2 equal to 8. So here we will put it. Now the thing is what? We can stop this case and we have to move for conclusion, right? Right. So the final stage, that is final stage means week 1 to the starting place. Week 1 to starting place, right? So that is for the initial week. Initial week means what? You are the starting, the project you are starting, right? In the project starting, no labors required. So that is the meaning. Here I'll put 0. Against the first week, the minimum labors is 5, right? That is going up to 8. it, right? So in this case, again, you'll put the formula here. You'll observe this case, right? The formula is, right? So this is the first week, 5, 6, 7, 8, and in the initial week there is no labors required, therefore we will put 0, right? So substitute all these value and you will get 33, 36, 36, 35. So the optimal is, that is the minimum is 33. It is given by x1 equal to 5. That is the thing here. Now that's it. We are come to the initial stage, right? So that is the first initial week. So based on this we can observe now. Now the thing is what? The optimality is given by 5 with 33 numbers. So we'll go back. The optimal solution is determined. So from the table itself we can observe for each and every week. So the first week it is observed the minimum levels is 5, right? So in the question itself it is given, right? For the second week 7, that is this is B1, B2, B3, B4, B5, right? And actual laborers is meaning is what? Actual laborers, that is optimality. Here we are going to talk. So actual laborers is xi asterisk. In the week 1, in this table we observe it is 5, right? Similarly in the week 2, we observe the optimality is 8, right? Optimality is 8. So how do you get this optimality? So among these I have to choose the minimum laborers. So here among these the minimum is 9. So that is the things here. Put it. It is given by 8, right? So here. So it is given by 8. So that is the things here. I will put it here, right? Similarly, going for week 3 table. So this is the week 3 table. Now among these, this 6 is the minimum. Therefore, I choose that is my optimality. So this 6 is given by 8. So that is the things here. So similarly, going for the previous week also, that is week 2 in this case, right? So week 3, sorry. So here it is only one choice, right? So 6, that is given by x4 equal to 6. Right. So similarly the previous case, so among these, so you should not consider this 0, right? So it is meaningless. Therefore among these, this is the 6, so it is given by 6. All these things we will put it in the final conclusion table. So here, so 5, 8, 8, 6, 6. So this is the given by the actual laborer force, that is xi asterisk. Now what is the decision you are going to take? Right? What is the decision? So maybe if you want, you can compute here. That also you can compute it. But I'll go here first. I want to talk about the decision. Which decision you are taking? So in the initial week, that is week 1, we have here 5 laborers, right? So that is keep it. It is fixed 5 laborers in the week. So therefore, initially I have a 5 workers. So nothing. What I have to do? I want the 5 workers, right? Minimum laborer 5. Therefore, I am hiring 5 laborers. That is the meaning. Right? Minimum labors required is 5. So therefore, I am hiring 5 laborers. So that is the things I put it. So initially, 5 workers to be hired. Going for the next week, what is the things? The second week. So 8 laborers required. So what is that meaning? So already 5 is there. Now we want 8. So what is the things? 8 minus 5. So additionally 3 workers you need. Right? So additionally 3 workers need. So what is the things? You have to hire 3 more workers, right? So that is the things here put. For the next week, week 3, so in the previous week you are already hired 3, so therefore 5 plus 3, 8 workers are there. For the next week 3, again you need only 8 workers. So already you have availed 8 workers, right? So therefore no change, right? So already you have 8 workers. For week 3, you need 8 workers itself. Therefore 8 minus 8, therefore 0. There is no workers you are going to hire. That means no change, right? So you can continue your project, right? Now going for the next week 4, you need only 6 workers, but you already have here 2 workers. So what you have to do? You just fire that workers, or in other words, you are going to sack that workers, right? You are going to relieve that workers. That is the meaning here, right? So 6 minus 8. So you are having excess workers. You are going to relieve them. Right, so 6 minus 8, that is minus 2. What is the meaning? Fire 2 workers. Just you are going to ask them to resign, or you are going to sack that workers, right? Terminate that workers. That is the meaning fire two workers. Now again, based on this week 4, now for week 5, you need 6 workers, right? So already 6 is there. Therefore, you are not going to hire any peoples, right? Any workers. Therefore, you can continue the same 6 peoples. Therefore, 6 minus 6, no change. So you keep it as it is. So what is the optimality here? So for the completing the entire project, how many workers you need completely, right? Optimality. So therefore just total this one. So 33. So but here you are given minimum 30 laborers. But the thing, if you're going with this minimum things, you cannot able to complete your project within a certain stipulated time. So in that sense, what is the things you need additionally 3 workers. So this will be reflected here. It's also so in the initial stage, right? The 33 workers. Maybe you can apply this case, or maybe you can conclude with this case also. So this is one of the nice example for the workforce size model, right? So I hope so. You can clear about this topic. If anybody need any uh, clarification, maybe you can raise by mail, or maybe when we are meet it. But if I think there is no time, maybe you can utilize this PDF material. I will send it to you, and you can just watch this my lecture. Any further clarification, you are always welcome to raise it. Right. So I will stop here. I hope you are enjoying my lecture. Thank you. We will see you in the next class. Thank you.